Hello, sir. Hello, sir. Prashanta, sir. Prashanta, sir.
Hello.
Yes, sir.
Presentation is showing there.
Sir, please stop your presentation. Let me introduce you, then we can continue within 2 minutes.
Hello. Hello. It's not.
Sir, sir, please stop your presentation. Let me introduce, then
Okay.
I can start with your session, sir.
Okay. Okay.
Good evening, everyone. Welcome back to the Atal FDP. In the last session, we learned about the working followed by the Indian Bureau of Mines. Next, we'll start with the uh, other session. Now I will take an opportunity to introduce the today's speaker, Dr. Prashanta Kumar Behera sir. Sir is presently working as an assistant geologist at a Geological Survey of India, Kolkata. Sir has completed his BSc in geology and MSc in geology from Barampur University and PhD from IIT Dhanbad. Sir has published a research paper in a various international journals and a conferences of repute. As a assistant geologist, he is holding a responsibility of a NGCM project at a Geological Survey of India. The topic of his today's session is a landslide morphometric classification of landslides and susceptibility analysis. Now I request Prashanta sir to kindly start with the session. Sir, please start the session, sir.
Hello.
Yes, sir.
It's showing. My presentation is.
Sir, slides is visible. You can start it in a presentation mode.
Okay. It's okay. Full
It's
press.
not loaded. Sir, in another tab, it's open.
Sir.
Sir, it maybe in another tab, it's open in slide mode.
One minute.
Yes.
It's not working. Now it's okay. Well,
We are not hear your screen. Now it's loading. So you can start the presentation, sir.
okay, thank you. Good evening to all. Myself, Dr. Prasant Kumar Behera. I'm working as Assistant Geologist, Geological Survey of India, Kolkata. And the topic of presentation is today the title a landslide morphometry and classification of landslide and susceptibility. So before I proceed to this next slide, I will have some idea about the landslide. Mostly the landslide is generally occur in the Himalayan region and some part of the southern part of the western region also. The basic difference is the northern landslides are more steep slopes, whereas in the southern sides, landslides are very slope angle is very less. So before proceeding this, so we'll discuss why does a slope fail, factor influencing the slope failure, purpose of study Q, purpose of study, landslide types and process, morphometric and geological mapping, landslide susceptibility analysis, macro scale, 1 is to 50,000. First, we have to know what is landslide. It's very common thing and it's very known definition. The movement of rock mass, debris, earth down, slope down due to the action of gravity. This is the common definition. And the according to Gordon, 1991, the movement of the mass of rock, debris, earth down of slope. The two main parameters generally affect the landslides: the increase in shear stress and the decrease in material strength. Why a slope fail? Generally, slope fail occurs due to the shear strength of the slope forming material must be less than the shear stress required to equilibrium. That is called factor of safety. Resisting force upon the driving force. If the resisting force is less than the mobilizer, then the slope will be firm. Before any type of failure, that slope that we have to make and calculate the stress acting on each slice, and it will calculate the factor of safety. Factor of safety is nothing but it is a resisting force upon driving force. If the factor of safety is 1, that is critical stable. If the greater than 1, that is stable, and the less than 1, it is unstable. And these are the parameters that generally is essential for the cohesion, slice base length, base long, base normal friction angle, slice weight, slice base inclination. Factors generally influence the decrease in shear strength. What are the factors? Generally, increase in pore pressure. Generally, what happens when the increasing pressure develops, when the rainwater percolates into the soil mass or rock body, it develops the water pressure. Due to the water pressure, it reduces the shear strength of the materials. Second thing is that the fracturing and shearing, cracks, development of tension crack in the crack of the crown portion of the shell that leads to the development of sliding, swelling. Also, development of lichensite also impact the decreasing shear strength. Decomposition of filling materials creep under the sustained loads. Leaching, strain softening causes the brittleness, heterogeneity of in composition. Weathering also when unpatterned influencing factors that affect the shear strength, cyclic load. Factor influence the increasing shear stress. What are the increase in the part of the factors? Loads on the top of the slope, water pressure in cracks on the top of the slope, increase in soil weight resulting in the increased water content, excavation of the bottom of the slope, drop in water level at the base of the slope, earthquake shaking also one of the important factor that influence the shear stress. Generally, what are the causes, main causes and mechanism? There are three: physical causes, natural causes, and morphological causes. Intense rainfall. In physical causes, there are the intense rainfall is there. Intense rainfall due to intense or the prolonged rainfall, the slope may be chances of failure. Rapid snow melt, rapid drawdown of floods, earthquake also, and volcanic eruption, freezing, thawing, weathering, shrinkage, swelling, weathering also important physical causes for the landslide. Natural causes that includes geological causes, weak materials, suppose weather materials, shear material, jointed fractures materials, adversely oriented measures, discontinuity, bedding, systemicity, adversely oriented structural discontinuity, fault, unconformity of contact also causes landslide. Morphological includes tectonics and volcanic uplift, glacial melt outburst, fluvial erosion of the slope toy, wave erosion of the slope toy, glacial erosion of slope toy, depositional loading shock and its test, vegetational removal by frost and fire drought. So this is what is happening. So here you can see the plants are tilted due to the creepings. Due to this is the leading of the development of the landslides in future. They have the step and the state forward. These are the features generally what you and occurs. These are the features and geometry of the slope. When you see the landslide, you must think about the what are the features that develop in the landslide from the crown, that is top portion to the toe portion, and these are the main scarp that develop in the top portion and the leading to forward of the head and the depleted mass. The failure surface is either circular or non-circular or parallel, depending upon the material. Features of geometry. The ground portion, this is the place of the top of the high sphere. The main scarp is the visible part of the surface of the rupture, which is undisturbed ground. Head also the connected between the displaced material and the ground. This is the top portion, and the minor scars are developed due to the differential movements in the sliding body. Main body, that is the main body, and the surface of rupture. This is the surface of rupture. If the loose material, then the surface of rupture is circular. The surface of rupture is depends upon the material property of that material, whether which type of metal is there. And the toe of the surface of the rupture. This is the toe portion where the landslide extended up to the toe portion. These are the types of landslide. First is the rotational slide. Rotational slide generally develop the loose sand materials, whether there is a circular develop, there is a circular plane surface develop. And the transitional, generally transitional landslide, where there is a parallel features that is joint and the planar features that accounts that develop the transitional slide. Block slide also, rockfall also, the free falling rock body from the high altitude. Toppling, debris and divergence, earthquake, creep, lateral spread. These are the types on the basis of the types of movements, types of material. There is some classification that developed by the Gordon and Verne, 1996. The fall, rock fall, the fall, the bedrock is if the bedrock is rock, then the type of movement is fall. Similarly, the loose grain soil debris material, the type of movement is fall also. Fine gulls at fall. Similarly, topple, slide, lateral spread, follow, and complex and compound nature of movement varies from the different part of the slope. So, what is the transitional geometry? Bedding planes and quick seams geology of dedicated failures geometry tendency of exhibit only the displacement at the failure within the limited settlement. Handcraft lands to be caught. Generally, what are the characteristics? Main characteristics: shallow depth failure, wide long geometry with respect to the depth, clear failure, a transition between the subsurface material, tend to occur gentle terrain. But the rotational, generally it is loose set material, weak soil, tensile strength, and the presence of cohesion, relatively uniform soils material. This rotational slide in generally occur in the mines or in open cast mines. You can also, so these are the dumping failure. You can get the rotational geometry, the relatively uniform soil deposits, low mobilized friction, gentle slope geometry. Then you can get the reversional geometry. And then the curvilinear, the surface of failure is curvilinear shape, particularly high hand strap, head strap. concave capture, and the rotation body of settlement. And the is a rock fall, there is very rapid to extremely rapid movements. No shear displacement takes place. The material subsequently run down by mainly by falling, bouncing, and rolling. Topple also same thing that involves overturning the material forward position of the slope mass about the axis below the center of the gravity, extremely low to extremely rapid, driven by the gravity and sometimes the water or ice in mass. Slide. The movement of material along the recognizable shear surface. Transitional cells develop the movement parallel to the planes of weakness, occasionally parallel to the slope, occurs when the geological discontinuities such as joint deep towards the valley strike deep less than the slope inclination and widening cracks just had the many of the indicator of the inlet value. These are the example of the joint. In field, we generally measure the different type of how many sets of joints develop in the in the rock body. That it will be helpful to present to calculate the factor of safety. Mesoscale. There are three scale: mesoscale, microscale, and site-specific study. In generally, what we do in landslide survey, mesoscale landslide susceptibility analysis. The main thing is that required large scale landslide investigation. To understand the large scale investigation, we cannot predict, we cannot go to the field. We can from here we can see the landslide investigation. It's an important landslide hazard management. Roadside, railway corridor, hill settlement around other infrastructure project to address the specific issue, roads, railway, identify the unstable zone for detailed study. Stability of reservoir also, the susceptibility analysis also required. Facility of selecting the site that are less prone to the ground instability, enables the delineating the unstable the landslide and prone area. Help in assessing the requirement of surveyability suitable environmental program by adopting the effect of migration vigilance. Selection of base map. How to select base map and map units. Preparation of topographic base map managed to 10th scale conventional survey methods. Total we generally total station. It is time consuming as well as it is very difficult. 10-meter resolution cartodem and 2.5 catastrophe image can also use for mesoscale landslide studies. 1.5 meter dam can also use to another alternative option that shows similar representation of terrain features, 10-meter resolution cartodem, and is freely available. This is the flow diagram. Before any type of validation, we have to follow the flow diagram. First, we have to collect the dam data or base map. We have to prepare. Then dam variety, different varieties, base map, slope, aspect, geometry, canal, and drainage also required. Field study, which includes different type of altitude measurements, historical records, whether there is any incident, incident happened in the past. This remote sensing data also required, and then we will collect the samples. Then we will proceed for the geotechnical studies that includes the C5 strength and rock material, whether there is cohesion and angle of internal friction of the rock. And then we will finalize the domain map. You have to prepare domain map and thematic maps. Preparation of data, integration in GIS platform, and preparation of susceptibility maps separately to each domain. And then we validate whether it is a susceptibility. Yes, then okay. Otherwise, we will go for the other alternate method. Let's say domain map. Let's say domain map represent the area having the similar physiographic and geological characteristics that control the type of landslide occurring within it. It also helps in understanding the dominant landslide process in the respective domain, evaluation of thematic control of landslide process in each domain. Criteria. What are the criteria used for mapping landslide domains? If the debris pool is domain, if the classes, then the area occupied the column and compact debris, loose debris, slope was immature soil. If there is a class under the earth failures domain, area occupied by in situ and transported soil. Rock failure domain area with rock cover. No landslide means the area where there is no chance of initiation of landslide, like river, water body, and alluvial material deposited within the river in the terraces. And for the landslide domain map, you have to prepare each domain set, debris slide domain, rock slide domain, and rock slide domain, no domain. Then you combine, you prepare the domain map. These are the domain map. And understanding the landslide susceptibility is very much important. The red color is showing high prone to the landslide, and the green is moderate, and the yellow is showing the low zone susceptibility. Then comes to the what are the steps generally what we do. Landslide detailed geological mapping to a building material morphometry, location of monitoring the stations, identification of scars, zones, transit, other physical features, preparation of geological section. You have to go in the field and you collect the data. Whether you have to plot, you have to prepare a geological section, and the site specific morphometry classification of microdomain, kinetic stress, admissibility, and domain specific SMR modeling. Then we put the different parameters that you collect from the field and the geometrical property. Then you prepare a geometrical model that we have to put the input parameters, whether and we have to calculate the factor of safety, whether the slope is stable or unstable by increasing the saturation condition. This is the water condition. The worst condition, the factor of safety is very less, and you can calculate the factor of safety. We have to know the whether the slope is failure or stable or probable type of failure. This is the field photograph. What I'm seeing is the retaining wall depth that was created for to stabilize the landslide, and this is the huge drain that is that has across the landslide, and you can see that is the road is down slowing. That means that there is some the landslide is occurring from the top of the person, and it is shrinkage due to shrinkage, and the road is down slope. These are the cracks that develops on the roads that indicates the initiation of landslides on that region. So some common slope stabilization measures: removal of slide materials, regenerate the slope, flatten the or reconstruction the slope, relocate road and to new stable location. Slope drainage such as deep cut trenches, horizontal drainage you have to construct, design of construct buttress and retaining structure and rock anchor. These are the all the other methods are there, but these are the common method that we have to follow. Thank you.
Okay, sir. Now I request participants to kindly ask the question if you have any.
Okay.
Sir, in a second last slide, you shown one hill and a path which is going down to a downward side.
Which one?
One few images, yeah, the slide 28. The path is going towards downward side.
Yes.
At every hill,
Yes,
when
yes.
we
From
see
if you
from
go, this road is turn bend, then you'll go this down slope. That portion also you'll get this type of depression is there.
so such type of views are categorized as landslides.
And these are slippage, but the water slippage that is going far from many times. Okay, both is working. So in that way, the place is depressed.
Okay. Thank you, sir.
Okay. Thank you so much.
Thank you, sir, for giving a complete overview of a landslides, covering the types of a landslides and the classifications of a landslides. Thank you, sir, for sharing your valuable knowledge with all of us. Thank you, sir.
Okay. Thank you.
Thank
Thank you also. Thank you.
The participant's attendance link is shared in the chat box. Kindly fill the attendance. The participant's attendance link is shared in the chat box. Kindly fill the attendance.